Hi, my name is Michael Chow, and in this screencast, I'm going to go through the process of translating an analysis from R into Python. I'll do it first using a tool I'm developing called siuba, and then I'll do it in plain pandas. This is part of a broader goal I have to translate a wide set of materials from R into Python so that people can do comparisons across them and see how people in one language do it in another. Um, what I'll be using is a data set from a project called Tidy Tuesday. So for this week, it'll be the train data set. Tidy Tuesday releases a new data set every week so that people in the R community and other communities can run data analyses and compare the results with each other. So this is the data. And what I'm going to do is I'm going to take an analysis done by another person, Dave Robinson, and translate it from R into Python. Dave also posts his analyses on YouTube, so I'll link to his YouTube video also, so you can see this hour-long screencast he did, and this is the final product. All right, so this is what it looks like. One thing I've been doing as I prepare to do these screencasts is I just check the libraries he uses to see if there's anything new or funky going on. This one's pretty straightforward. He's imported the tidyverse and the scales package. So this is a common suite of tools that people use often doing data analysis in R. And this is often used in plots. I'll show you the tidyverse very quickly. So it's a whole suite of packages that are designed to make data science really nice. I'm a big fan. And so you'll see sort of how these tools map onto Python. All right, so I already did some of the work of polling his script. So this is Jupyter Lab now. I'm going to open the script in a tool called JupyText. So even though it's an R markdown, let's see, let's Python kernel. So even though it's in an R markdown, if I just open the raw file, you'll see it's just a text file. There's a really great tool called JupyText that lets us open these as notebooks and then save them back to this R markdown file. All right, and you'll also notice that this is all R code. So what we can do is we'll probably leave this, well, I'm just going to comment this one out for now. What I'm going to do is I'm going to turn these into blocks that run in R using rpy2. So, I need to grab rpy2. I did it for another analysis, US PhDs. Let's see, so should be right here. All right, so load that in. All right, I need to uncomment this. All right, so now we can use this R cell magic. I'm gonna go ahead and just try to run this and see what it dumps out. All right, great, so it seems to have worked. And it output this full trains. One thing we can do is we can say, hey, give me back the full trains data in Python. So now I can actually run full trains and get this nice printout. There's also a nice tool I can use called QGrid. I'm gonna open it here. So just copy it out. I think it's just show grid. Yeah, so let's grab that too from QGrid, show grid, show grid. Oh, this is a super big data set. So let me, I think one thing we can do is set it so that it doesn't cram everything into the space. It lets you scroll between them. Let me see. Is this, shoot, I can't remember what it's called. I think, so we'll change force fit columns to false. All right, so we'll do grid options, force fit columns. Oh, nope. All right, false. Okay, great. So that worked. All right, so let's see. Lots of different variables. It looks like this is for each station and each arrival, I'm guessing on a different year and month. Yeah, what were the number of trips? So taken from this place to this place. I won't dazzle you with my attempt to pronounce those names. How many were late? How many were delayed? We can also look at the Tidy Tuesday descriptions here, which are probably pretty informative. So, year it happened, month it happened. I think there's a small data set and a large. We have the large one. So similar things. Okay, so I'm gonna get back into the script just so I can try to quickly do this translation. Let me take out, well, I'll just leave it commented. Okay, so what he's doing here is, let me go, I'm going to go back into this folder so I can open a new file. I'm just going to, for now, I'm just going to duplicate this and rename, I'll rename this one siuba. So what he's doing here is he's creating new columns, PC late departure, just dividing these two, and then he's arranging, just sorting the rows. And then this important one, he's filling in service. I wonder if it has missing values. Let's do these steps and then see what you need to fill in. So I'm gonna open this as a notebook. Great, cool, cruising. So now we can split these. I'm gonna press Command B to close that tab. All right, so full trains. And then I can also press Command Shift D to make this full screen. So now one can take up the whole page. This is the, yeah, great. So, all right, I'm gonna start with Python by importing pandas as PD. Cool. Get rid of these. Replace this. This will be pd.read CSV. Yeah, sorry, I don't know why I paused there. I think it can read from URLs, so we should be okay. And then I'm going to import from siuba import. I'll keep track of my imports here. So _mutate, arrange, and then fill. I don't remember if there's a fill. Okay, we'll have to do that one manually. All right, so we're reading it in, and then we're mutating. Oh, probably don't want that arrow. Actually, I can just keep these now. One big difference is, so with siuba, what we'll want to do is we'll want to precede these with an underscore. So, or you can just go wild. You can put expressions in, and it uses lazy evaluation. Here we need to use this special syntax with an underscore. So this is bring it to title case. I think that essentially what we can do is, I'm going to read this in as a demo. So full trains, just to show you. So you do something like full trains dot arrival station, just the one we want to move to title case. Dot string dot, I think title. Yep. So that just changes the first to be capitalized. So, oops. Yeah, because they're uppercase right now. So dot str dot title, yoink. And then similar, so dot str dot title, great. And then date. Let's see what exciting things are in store for us with the dates. So, year and month. So he just combined them into a date. So That's a good call. I actually don't know. I'm sure there are better ways to do this in pandas, but I'm going to do the same. So basically the crux is we want to combine the year and the date columns. Let me just try this. This is an integer. So I'm going to just turn it into a string real quick. And then I'm sure there's a better way to do this. So I'll look it up afterwards. Life is short. Great. And then, so we want the year. Oh, we're gonna have to do a little bit of formatting actually, because we wanna, notice, we wanna be a little bit careful to keep, we don't want the month, if the month is 9, we want it to have a 0 in front of it. What we can do is, in Python, in string formatting, you can do something like this. If you want it to have a 0, 1, I think you do something like this. Yeah, so that puts 2 decimals behind it. So, oh. Yeah, so we'll want something like, okay. I'm gonna have to look it up. Python string formatting leading zeros. I think actually what it is it an I? No, yeah, I'll have to check. Let's see. So, yep. Oh, okay. So close. So 0 to D. Great. Well, I wonder if there's a good way to do this. Maybe using a val or something, but in any event, we can do that here. So this isn't going to be pretty, but I'm just going to do the same. So 0 to D. No, the year doesn't matter. Year's cool. We got it. So as type string months dot, I'll apply here 0 to D. Great. Dot format. Let's just double check that this works. Yeah, and then we'll put this 0, 1 here. Yep, and then we need to just do the, so this is by no means the prettiest solution, but it'll get us there. So great. Let's put this in, and then it's probably pd.to date, I think. Date time. Be nice if we could just get the date. I'd have to look it up. I think you can specify the resolution here, so that might be an option. You know what, since it might be unit, but since this gets the job done, I'm gonna keep going. So I'm just gonna put this one in a lambda, because it's very long. All right. Let's see how this goes. Comment these out. Oops. Keep this. Put a closing parentheses. Yes, we're in. Let's see, full trains. And let's just select. I need to add that to my import. We'll select year, month, date. I don't know, departure, station. Yeah, it looks good. So in another world, I'd probably give that a closer look. I'm going to keep going. So let's get this arranged. Again, with siuba, I just precede it with an underscore. And then if I had wanted to, so this will do it in ascending order. If I wanted it in descending, I could put a negative sign in front of it. So now month is descending. Okay, great. The last is this fill. Let me look at the service column a bit just to understand. For some reason I have a little bit of trouble remembering exactly what. Oh yeah, I forgot we had this. Let's see. I'm actually forgetting exactly what fill does, so I might need to look it up quickly. I think that it's used often to replace NAs with 0, but I might just be totally spacing here. So service, great. Let me double check. I'm gonna open, can't open that. So let me Google it. It's tidy fill. Yeah, so, that's right. This is used to forward or backward fill. So in pandas, we can use the ffill method. So here we could do something like mutate service equals service dot ffill. Okay, great. Looks good. Let's just glance. But I wonder, I'm gonna check quickly also to see, I just want to glance at where there are NAs. So just to see what we're filling. Sorry. So siuba imports its own filter. There's a built-in function with the same name. Often I do import star from siuba because at this point I'm very familiar with the objects it brings in. It's my bad. So yeah, there are all these service, and maybe they are. It sounds like. Well, I'm curious why. Huh. Yeah, I don't know. Let me read what service is quickly. So, service, type of train service. Yeah, I guess there are cases where service isn't filled in. It's not clear to me. Let's grab, maybe just to see, let's just grab this row. So I'm going to do .iloc, or let's just do .loc 38. Well, this is the index. So iloc stands for index location 3874. Oh, I did something wrong. Oh, okay. I forgot that loc is the one that uses the index. My bad. So let's grab, I don't know. So what I'm going to do is, sorry, I wanted to check that in the unfiltered data. So let's see. Okay, great. So 3874, I'm going to just look, I want to go one back. How do I, okay, so I actually realized one thing I've never done is look up the actual position of an index. I think I could do something like where it equals 3874, and then with NumPy, you could do np.where. There's a series method for it too. Is there one on the... Oh yeah, so the index has a where. So you do something like full trains.index equals 3874. No, something. Let's check. Huh. Yeah, I'm not totally sure. Might have to look into that. I'm not sure how it works for an index. Oh, the issue is that the way pandas where works differently than NumPy's where. What pandas does is it returns the value when it's true and replaces it with NaN otherwise. What NumPy's does is, well, at least for cases like this, it'll actually return the literal position. So 3. All right, great. So now we can use iloc to get position 3. Notice it's the same spot. Now I just want to like C to 5, I guess. So yeah, notice that it's the same departure and arrival station. Service is just missing. So he just has forward filled service. I don't know if that's the right choice. I'd need to look closer at the data to understand. But just to summarize, so what I wanted to do is I wanted to find the actual, this is an index, and I wanted to know what's the actual row number for that index. And there's one thing I noticed, there's a key difference between the series.where, panda series where function, and the NumPy where function. This one's able to tell us the exact position of the thing that matches this. All right, so I'm gonna say, I'm just gonna mark this difference between np.where and pd.series.where. Great. Anyways, we did it. So let's take this filter out. Let's get this forward fill going. Cool. So we've got our full trains. Where did my great preview command go? Did I delete it? Oh, that was dumb of me. So wait, can I? So I gotta check show grid again. My bad. So force fit columns false. Grid options, yeah, great. So grid options, force fit columns false. Okay, and then full train, I think is its name. I've done something wrong. Full trains. Boom. All right. Doing great. So, all right, so that's just reading in data. I'm going to make a new section. I pressed 2 to make it a markdown cell. Read in data. All right. Then I'll make this another section. I don't know what it's called yet. Let's see. So here it looks like he's just filtering out a specific month of 2018. It's pretty easy for us to do. So change this, go here, and it's basically the same. I'm gonna put underscores here. All right, good. So, oh wait, obviously I can't run the rest. I'm gonna comment that out. I press command slash, the key with the question mark, to comment it. Great. November 2018. Sometimes I keep the results, I just run them on the cell below. Sometimes I remove the assignment and just let it show up here. All right, so not surprisingly, just a single year and month. Let's see. Oh, I need plot 9. So, and here I will import everything because it's just very convenient to have all of the functions for plot 9 in their own space. So here we go. So it actually implements all these things. Plot 9 is a really great package. I highly recommend it. This should work. I think this will also work out of the box. Let's see. Oh, I need a closing. Okay, something. Oh, the one thing we have to do is for plot 9, we need to put these in strings. Oh, and we don't have percent format. I think I actually formatted it as a percent in my previous analysis. Let me see. I'm not totally sure is the problem. So let's get rid of this for now. It would be something like this, I think. Yeah, so what we can do is, let me paste this in and then I'll explain a little more about it. So we can't use percent format. That's from the scales package that Dave imported. What we can do is we can set labels and then use a function which takes the original label and then we format it. So in a sense, this snippet lets us change a value to a percentage. So let's say if it's 0.5, 50%, right? If it's 0.25, 25%. All right, so, and this is saying use 0 decimals from the number. Let's see if that worked. Yeah, nice. So here we're looking at the percentage of trains that were late in 2018, November. Let's take a look at this other one. I'm going to move this into its own cell. So it has, oh, I did something wrong. Oh, I need to copy it so that the inputs can all, the outputs can all show up. Put this here. The other thing is I can do some black formatting, which is useful just for some quick cleanup. So this replacing the pipe with the greater than. I'm gonna move these all back. I'm gonna move them out too. Let's see this mutate. So again, it's a pretty classic set of actions. Oh no, we have a fact FCT lump. So that's from a package called for cats. Let me pull it up. For cats is a great package. Basically, what it does is it lets you set categorical variables, and these exist in pandas too. And basically, what this is used for is to reorder things. So oftentimes in a plot, let me, that's not useful. So let me show this plot, and then I'll show how for cats is used. Nope, we gotta do our own percent format. You know, I'm going to, I'm just gonna create my own function up here called percent format. Notice that he calls it, I'm gonna do this. So I'm just gonna set it to be this lambda. And then what I'll need to do is I'll just need to take the percentage sign or the open close parentheses off it. Ooh. Oh, so again, we need to put it in strings. Great. Oh, that's not good. So, what could have happened? Let me try getting rid of this scales. Oh, that's not good. So, something bad has happened. Oh, no, it was just a very big, very slow box plot. And this is kind of to be expected. So basically the FCT lump problem is like, this is an incoherent plot. And the reason is there are a lot of stations in here with very little data. So notice, so I'm going to comment this out. So this is the data. And what I'm going to do is, even get rid of this, mutate. Sorry, there's a lot of comments floating around, but clean it up. I'm going to count. So notice he was plotting departure station on the x-axis, percent latest departure on the y-axis. Our issue was that there was tons of stuff on the x-axis. So if you count, for example, departure station, I've got to import count. So if we count it, you'll see there are tons of ones with n equals 1. We can sort to see just the ones with, oh, that's an R thing. Notice we have a few, right, that log a fair amount, but then we have all these ones with only a single entry. These are ones that I'm guessing because the data is logged per year and month, that these are ones with maybe a train that runs once a month or something. I'm not quite sure. Let me pull. I'm gonna pull the Paris station just to check my intuition. So when departure station equals Paris. Yeah, year, month. Oh, you know what? It's going to, so it's leaving from Paris. It's going to different, it's arriving at different stations. So all these other ones that we're counting are only servicing like one route, maybe going to one station. So it could be really hard to view our plot if we only have a single data point for each of these. If we're viewing percentage latest departure. So what he did was he used FCT lump. That means essentially we want to keep only 3 departure stations, the one with the most observations. So that would be here. We want to keep essentially these 3. I think it has special behaviors for ties. What we can do is siuba has right now, oh, not dplyr, 4 cats. So we can import FCT lump. Let me see if this works. We gotta do this. Great. So we did it. And I think we'll know that we did it by, well, let's plot it. That's a good way to just quickly check. I think, I can't remember my shortcut to do black formatting. Let's see what happens. Oh, you know what? Maybe it's formatted. I don't know what's going on there. So, just move this, do a little cleanup. Oh, I think there's probably an error. Nice. So notice that now all the ones with really few entries were grouped into this other category, and then the ones with the most observations were kept as they were. So this is a super convenient function. And notice these functions in siuba work on pandas categoricals, similar to R. If you're not familiar with a categorical, I can't remember how to make it. Let's see. A, B, B, C, D type. I think it's category. Let's see. Categorical. Lowercase category. Oh, I did it. So notice it's a special type of series. And the reason it's special is that it basically, I can't remember where it stores things. It basically stores 2 pieces of information. The different levels, I think that's nope. I don't know where it is. It basically stores these labels and then an index to them. Let me double check. Sorry, my autocomplete isn't working great. Oh, it's got tons of methods on it too, so this might be kind of hard to find. Basically, it looks like it has all of the classic series methods on it. Yeah, I don't remember. All right, I might give up here. Actually, one way we can look it up, I know, is by looking at the docs for categorical. So I think it's categories and maybe here we go, categories, codes, and whether it's ordered. So we can do categories. Oh no, underscore. I hate my life. So yeah, I don't know. Let's see. All right, one more try and then I'll give up. So attributes, categories, codes, ordered. All right, so that seems like we should be able to do it, but yeah, I give up. I think here, categorical dot categories. Yes, that's, I don't know what's up with that, but then I think labels, I don't know, levels, values. All right, I give up. Anyways, you can see the categories here. So it has an index with the categories. We're so close. Let's just finish this out. So categories and codes. So cat is like an accessor. It lets you access all the sort of like categorical specific things. Great, so that's not a good way to print it, but we can do it like this. So here, categories is an index. Codes is this kind of special, it looks like, it actually kind of looks like a series, but I don't think it is. Oh, it is. So it's a series mapping where each of these labels is. So A is the 0th entry, another A, B, which is the first entry here, is the second and third in the array. All right, so that's a little diversion. Great. All right, we gotta get a move on. So cool, so we got this plot cooking. Looks like a lot of late departures here. And actually in these individual ones, maybe that's not too surprising. Some of these might only service a few routes per day also. Let's see, so I'm gonna start on this one. I think that mutate was already commented out. I'm gonna double check quickly. Oh, actually this is a pretty short analysis. So yeah, these two were commented out. So that's right. All right, let's get this teed up. Great. Change these. Next time I might focus on some sort of like tools to automate replacing some of these things. But we'll need fct reorder from siuba.dply.forcats. Nice. Reordering and lumping. That's my kind of stuff. All right. I'm going to comment this out just to see that this works. Nope. What have I done? Oh, no. So basically, FCT lump, I don't think we've implemented the proportion. Basically, what he's doing in R is he's saying, hey, we only want to keep 1% of the levels here. So there are a lot of maybe there are a lot of arrival stations. Let's see, November 2018 count dot arrival station. Don't need to sort it, I guess. Let's do sort equals true. Oh, okay. There are 58, so I don't know why you would keep 1.1. I can't, maybe I'm wrong about FCT lump. Let's double check. So prop preserves values that appear at least prop of the time. All right, so as long as there's that proportion of values, so it would probably keep, guessing all of these, any with more than 2, and maybe that's something. So there's something we can do. Let's see. We can work around this really quickly. Let me take a look here. So he wants to keep things that happen over 1%. What I'm going to do is I'm just going to cheat. I've seen the counts. I'm going to say we want to keep maybe the top, I don't know, 14. And then we can run his R code and see where that gets us. So let's keep the top n equals 14. One issue is how it handles ties. We'll see how that goes. But cool. So we did that. We can double check by counting the arrival station. It has 14, so that's great. Where's the other, though? Is that? Oh, I don't know. So, oh, am I? Oh, there's other right there. So, great. Cooking. Let's get this mutate going. FCT lump, departure station, percent latest departure. I'm gonna go here. Departure station. Nice. So I'm gonna count. So we have November 2018 dot size. Wait, data frames dot size method is not. Sorry. So there's a little context. Dot size on a data frame is different from a group data frame. I was thinking of the number of rows, so that's 130. Dot size for a regular data frame multiplies these two numbers. All right, so there are 130. He's keeping 1%. I don't know. Let's just like take the ones again. The top 14 seems ample, and then I'll get to work implementing the prop argument of 4 cats after this. Great. Let's see how this goes. So let's just keep moving. We're going to group by arrival station, departure station. The reason siuba uses this special syntax in group by is you can actually do other things. You could do like this. I mean, this doesn't make sense, like +1. You can actually have expressions in here. So like some group, kind of like combining a mutate with a group by. All right, so summarize. Let's see. So we're adding num latest departure. So I want to use the series method sum. Total num trips. If I were really being careful, oh, I need to import the group by. In siuba and dplyr, it has an underscore. If I were being really, did I not? Oh, I need summarize too. So summarize. Okay, if we're being really careful, I believe that pandas and R have different behaviors for NANs. So Oops, I'm gonna do using numpy nan. Yeah, pandas basically by default when you sum, if it's all nans, it gives you 0. In R, I can show you on an R array, I guess. So we don't have it loaded here. Just gonna chuck this in here. In R, if it's a like this with an NA, it returns NA. So what we need to do, if we wanted it to be, oh, that's the wrong. If we wanted it to be identical to essentially what's happening in R, we have to specify the, I think it's isn't, let me double check. So pd.series.sum, I think it's isNA. Oh, skip NA. But there's also this min count. I can't remember. Yeah, so we'll do skip NA as false, I think. So it'd be skip NA equals false. Yep, and then you get the NaN back. All right. Anyways, let's move it along. So grouped, we're summing. We would do skip NA here if we wanted it to be identical to R. Let's put that in. Let's just be explicit in our translation. Great. Let's get this ggplot cooking. I'm gonna just try it with the tile first, just to make sure it works. Arrival station is not defined. It's defined now, so I'm ready to get this graph cooking. I gotta stop using the word cooking. So this is cool. It's a tiled graph of basically a heat map of percentage late at departure using departure by arrival. He probably rotates something here. This is a classic. Oh, how does this work? This actually, nope. Oh, sorry. So I think what Plot9 uses underscores, and I think also, oh, gotta add a plus. Sorry, it's getting a little hairy. Yeah, so Plot9 does expose this element text to you. Let's see what this does. I'm not sure if Plot9 supports this. We do have to take out, do this to % format. Oh, Plot9, I'd just like to take a moment to appreciate just how incredibly faithful to the original implementation Plot9 is. It's just like totally bananas. So, all right, but we got work to do. So, labs, this should be okay. I think, I don't see anything weird. Yeah. Oh, okay, great. And then, what is my hotkey for? I'm gonna look it up. So I pressed Command comma to look up my hotkeys. Alt Shift K. Okay. All right. I actually don't know how to get back to. Oh, that was weird. So okay. So now I'm gonna go back into this is called document mode when you only show one notebook. And what I'm going to do is Alt Shift K. Oh, I don't know how I feel about that, but sure. I'm gonna take this out just to clean things up. It feels a little gratuitous, but it is pretty nice, so can't complain. These are really long lines is the thing. All right. And we could group some of this together. We could also put this in like its own special function. To maybe make things better. I'm going to leave it as is for now. All right. So this is great. This is a heat map of stations with red indicating those with a lot of late departures. And this helps us break it down by departure and arrival station. So it looks like a lot of these ones here are late all the time. Late departing. Could be for a variety of reasons. All right. And then I'm going to, just to check my sanity, I'm going to run a lot of Dave's code now. So R, make sure it runs. Yep, and we got the final plot. No, it looks pretty similar. Sorry, there's a little bit of funkiness. Actually, we could fix that. I don't think he does this, but you can set ggplot to make this, for example, like a square. That I'm not totally sure if that would be the right move here, but it might help. Great. So that looks good. I think it looks faithful. Let's go to the next section. Remove this. Move this. Okay, yeah, we're making good progress. So let's cook. I'm gonna. All right, and then I'm going to translate the pipes. Nice. This should be okay as is. We can let black handle the formatting. Let's do this. Oh, there's already it's a header for us. So nice. Oh, I gotta fix this. Wow, I bet we could very quickly make a tool that tries its best to convert these. But that, to be honest, that would be a bit of a time sink. It's a dangerous game to play. Name departure station is not. Oh, here we go. Needed the underscore. Yeah, cool. So I'm going to comment these out for now. Just print this. Oops. Need the R block. Yeah. This looks great. So cool. I'm just gonna keep going. Well, let's take a sec. So this is looking over time now, later departure. This was just a snapshot of 2018. And that's really, I think it's really helpful in data analysis sometimes to do that. Grab, for example, like a snapshot in time, and then focus on, so you can see the dynamics here from departure source to arrival destination, and then look at the temporal dynamics. So, great. Get that arrow out of here. All right. Do this classic songy dance again. I won't worry about formatting for now. Single document mode. Let's activate. Cool. Move this down. I'll probably have to put some underscores, not you. So this is a good example of a special kind of group by. I'm going to use n equals 14 again as a substitute. And date. What is this? Oh, he's grouping by. I'm going to make it a little easier for me to read. Departure station and date. So considering departure station by date. Oh, you know what? We don't have summarize yet, but we can create an alternative. Basically, what summarize at is okay. It applies the summarize function to each thing that matches this. So every column that contains number, it will aggregate to give you the sum of that column. This might be most easily demonstrated by actually showing what this could look like. So what I'm going to do is I'm going to just pull out all the columns that start with, I think it's start with, it might be starts with, let's see. I can also open a console actually, which might be helpful. Oh no, I don't want it like that though. Okay, I've made a terrible mistake. So yeah, I think it starts with. String that starts with. So for all the string operations, you just need to remember it's using this special accessor .str that holds kind of all these string related functions. So you could do, this is a little bit cumbersome, but I think you could actually put a lambda in here. I'm gonna put the underscore, which works like a lambda. So let's see if that works. Oops. I think this did run though. Well, actually, it probably didn't because of the syntax error. Ooh, that's bad. So maybe let's not bother. Yeah, it's a very particular thing. There are probably better ways of doing that. All right, so num calls, and what we can do is you could think about actually. So if you think about it, what we're essentially trying to do here is say something like, what's a num column? So, okay, we want to sum num canceled trains. So we could write num canceled trains equals num of canceled trains dot sum. Oops, I gotta remove that. Okay, I'm struggling. In Python, you can't put a named argument before a positional argument. One thing we could do, we could either move date here, or I could make it a named argument. That's something I need to think more deeply about with siuba. So since in R you can have named arguments before or after. Okay, so notice that we just aggregated num of canceled trains, but imagine we want to do that with every number column. We want like num of late at departure, arriving late. So what we can do is we could either copy and paste many times, or we could also just make a dictionary of these. So like so call name, and then will this work? Call name dot sum. I've actually never really done this, but for call name in num calls. Essentially what this is, let me pull this op out so it's clear. I'll call it like summarize op. Basically what we did is we made a dictionary, and this is what, so in a sense, this is what an operation using this underscore syntax looks like. If we wanted to sum x, it'll actually make this nice little representation of what we're trying to do. So here we just made those for each of these columns. Every num column now is an entry in this dictionary with the corresponding expression for it. Let's do that. Let's put in summarized op. Okay. Summarize op. Cool. So that did it. I've thought about implementing things like summarize at, or dplyr in version 1's introducing a new syntax that I might call the cross, that I'll likely include. Okay, I think we need to import ungroup. I can check that in a sec. I'm just gonna go the full Monty because these are pretty straightforward. So this here. Oh, maybe I don't. Oh, yep. Yeah, we need ungroup. Ungroup. If you get lost, sometimes I like this table of contents. Oh, this is not the most thorough because we haven't added any headers, but it got us there. So that was pretty great. Maybe I didn't run this. It's definitely worth, really at this point, I should rerun the whole document but I'm afraid. So give me a sec to think about it. Doesn't have total num trips? Okay. I don't know. Let's see what we're dealing with. This is why I put the greater than on the same line as the verb, is you can comment it out. Okay. Yeah, so there isn't a total. Oh, I did starts with. I need dot contains. So string dot contains. Nice. And then we should be able to do this. I'm going to. Yeah, I gotta put it back. I'm gonna format in a sec. That took a little bit of time. The reason is that. That's great. So the reason this group by is a little bit slow is grouped operations. Custom grouped operations in pandas can be slow, and that's a problem I'm working on in siuba. You can read it. For example, there's a developer doc that discusses in depth how siuba is optimizing these operations, so that group summarize can just be fast without people needing to think about it. In the meantime, so if you notice, this takes a little bit of time. Just finished. I'm gonna import the experimental function, import fast summarize. Fingers crossed that it works. If not, though, it's in a folder called fast experimental. Notice that ran nearly instantly, so super fast. Takes a bit of time, and this is using the apply function method in pandas, which is like advertised as not ideal. So I mean, to pandas' credit, it's a very robust general tool, but it's not necessarily a fast tool. So I'm gonna just include fast summarize here, so we know. Cool. Let's go. All right, we're so close. So we just need to finish this off. Okay. Yep. And then going to put underscores. That should be fine. Underscore. This is it's just saying we want to order by % latest departure descending. FCT reorder is important because, for example, in your graph, you might want the station that's the highest to also be the highest in your legend. So notice that at least here, like loosely, the lines correspond to the height. Like in the legend, correspond to roughly their rank in this graph. It's the median. It's using the median of % latest departure, for example, a station, to determine where it is in the legend. Okay, so we should probably make sure that runs, though. Oh, did I leave off? I did not. Oh, I included an extra. That's not good. So, this might. Oh, we were doing so great. So, let me see. So I'm curious about by departure station month. That's not good. So unfortunately, something happened, and it kept actually the index. It should have been reset. Let me double check if I bet the slow method does fine. Yeah, I'm gonna have to fix. I think the fast method, it looks like it needs to, in some cases, drop. Be sure to reset the index. So just to reiterate, when I use fast summarize, it accidentally returned a multi-index, and I need to fix that. All right, that's why it's experimental. Okay, so, but let's see if that resolves. Nope. It might have something to do with the way factory order is being used. Let's see. So departure station month. I'm going to grab these columns just to see. Actually, what I'm going to do is then do a select of departure station percent later departure last. Great. Oh yeah, so last, I don't think there's a last in the data, so that would do it. Let's look at the columns. Yeah, I don't know what's going on. Let's see if we missed something in here. By departure station month. I don't remember. I do feel like I did miss something substantial, actually. By departure station. Are there 2 by departure station months? What was I even... I actually don't understand. What did I copy? Full trains. I got real turned around or something. So I don't even know. Oh, it's this one. Oh, but this is even commented out, I think, in his... No, I think I commented it out. So, sorry, I'm here in the analysis and I briefly confused myself. So, I'm going to copy these all to their own. Sorry, he redefined, I think, this below. But let's push it through this one since we have it. So there's the group by, summarize the ungroup. I don't know where. You know what? I think what happened is a classic notebook problem. I bet he defines last here, and then he maybe went back and did something. I'm gonna look up the word last in. You know, I have no idea. I'm guessing that something happened. I think if the notebook were run again, actually, maybe it would throw an error. So let's go ahead and skip. I'm gonna put a label on it, like summarizing departure station by month. Skip. Seems like the original analysis might not run, question mark. We could run the whole thing and just see. Okay. Oh, I don't know what's going on. Oh, I'm an idiot. Last is a function, is a dplyr. I think it's a dplyr function. In any event, he's reordering by the very last value here. So what we need to do is keep all this, doing great. But we need to use a function, and what that function is, I'm actually not sure how to grab the last value. I'm not even sure if it's supported in siuba. I think it might be something like we could pass the function dot iloc. I think -1 would work. Let's try that. Let's just define this and see. There almost certainly is probably, well, okay, almost certainly it probably don't make sense, but a function to do this. But I just want to check. Yeah, okay, let's just use that. So we got it. Looking good. Put last in here, see what happens. Whoa, okay, it worked. Sometimes I surprise myself. siuba's gotten big enough. It's not huge, but there are enough functions in it that I forget sometimes, like just how much a forecast has been implemented. And a lot of that is also thanks to Anthony Baker, who contributed some changes. So we got last. Okay, I'm gonna start putting these here. Oh, it's gonna look real ugly for a sec. Take this out like usual. Please. Oh, I flew too close to the sun. All right, so, okay. Cool. Oh, that's not right. So, what could be happening? It looks like almost a lot of the same stations. Could it be that, well, I could check what the value is. I think also I need to check exactly how we create labels. So I'm going to remove the labeling code because a number of things could be happening. One could be that actually percent formatting is doing something funny. So now this is a 1, basically. This is Geneve. So that's not in here. So we probably took too many departing stations. He has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, let's cut down to 13. Boom. Boom. And what do we got? Yes. Cool. All right, we're in. Let's wrap this up. So the last is this. Ooh, all right. Save the best for last. Okay, so let's just get into it. Equals full trains. Change this pipe. It's a classic group by. I think so siuba does have if else implemented. I think oftentimes doing some pasting, we can do departure station plus. Should work just fine. And then let's make sure. And then just departure station. This means if service is international, put this extra label on the departure station. Otherwise, just give back the original. That's a pretty good use of an if else, I think. So good job, Dave. Service year. I'm gonna just add arguments. Okay, this is a little scary. This is a lot of stuff. So month.name is probably the name of a column. I'm guessing for us it ended up being underscored. Let me double check. So full trains dot columns month name. I'm gonna do dot string dot starts with month full trains dot columns. Oh, where's month dot name? I don't even know. Does he define it somewhere else? Month dot name. I'm gonna search for it. Month dot name. No, I think that it might have. It's either a variable in R, which I've never seen. Oh yeah, I learn new things every day. So, I actually don't know a good way to do that. One way is we could create a date. I know one very hacky way. It'd be from date time import date. Oh shoot. Is it format? I haven't used these in a long time, so I give up. So let me Google it real fast. So I don't do a ton of stuff with dates. Let's see. Python create list of each month name. I just want each month name. Create list of January through December. This is the word. I might literally type it out real fast because just for the sake of time. So month names, I'll do January, February, March. Everybody's having fun. Woo. June, July, August, September, October, November, December. I think this is an important thing to do too. Like, this is a one-off task right now. So it's like, if it comes down to doing this quickly or learning how to create a list of months, I think it's probably better to just do it quickly, and then you can always revisit the issue. So but ultimately he's taking the month, and he's converting it to a name. Actually, that's a much easier thing that we can do, I think. Let's see. So because we also have this full date. So what we can do is we can do full trains, and here we have the I think we have the date itself, and we can do .date.dt.month, I think. Yeah, that gives us the month number. I think there's a way to get the month name, and it's dt. Let me look at the month. There's probably like a month name. Yeah. Oh, cool. Yeah, so that'll save us some typing. DT is like using .str. It's the date time accessor. So cool. So this would be date dot dt dot month name. Sorry, I was looking to make sure nothing funky would happen. And then he's using month here. He's using the numeric values so that he can reorder them. What's he? Yeah, okay. So he wants to end with the actual name for a month. See how that goes. I think we really should comment out to here. Just make sure that runs. We did a lot of exciting stuff there. So nope. If else, I need to import it. So from suba.dply.vector import if else. I think you can also, you can import it from just suba itself. Yeah, great. So it seemed to have worked. Oh, that's not a code cell. No. Dang it. Great. So, yeah, month here. Living the dream. So, we're going to do the same summarize type thing as we did before. Let's see. So, this is identical. So, I'm just going to copy it from here. I'm going to copy the full thing for now, just to play it safe. No, it's literally from the same, I think. This is also on full train, so I'm just going to use this. Summarize star summarize up. Oh, that shouldn't have run. I think this needs this. Yeah. And then we'll ungroup you. Okay. And then do the mutate. Oh. All right, great. And then the last thing is we'll need this to be like this. Wow. Oh, you know what? If this has a lot of groups, it will really bog us down. We could do fast summarize. Let's run fast summarize, and then I'll try to fix the indexing problem, just so that we don't have to wait for it. So yeah, notice that was much faster. That ran in a fraction of a second. We could also, so pandas for aggregations these are just doing sums of columns. So we could do like group by dot ag, something like, I'll show you. Oh. Yeah, with this, so this is just a group pandas data frame. And if we want to calculate the sum of all these rows that start with numcall, so that's summarize ops dot keys. Let me show you. Summarize op. It's just these columns. So what we can do is dot ag, and you could do something like this: num of canceled trains equals sum. Nope. Is that not? Oh, you know what? No, actually, I'm not going to get into this. This is nuts. So the ag function, you can't name things, but you can do this. So something like this. We'd have to choose the columns we want. So we'd put here, basically we do something like this: call names dot ag, and then you get it right. The downside is it's in a really nested structure like this. I also don't know why there are all these NaNs, so that's worth checking out. It could have to do with maybe the groupings or something. So, but this is another way to do it. You'd have to do some index resetting. All right, I'm gonna take that out for now. We'll have to redo it anyways when we do it in pandas. All right, so we got that. We're fast summarizing. Actually, maybe it's fine with the index, depending on the bug. I think I know what's happening, and you're not a code cell at all, so I gotta delete you. This cell's got it out for me. All right. Yeah, notice actually I could just drop the index. I think that what happened is I reset it, but I didn't use drop. So if I do reset index drop, or I don't know what I did. So drop equals true. We're good again. But it's, for our purposes, actually, it doesn't matter here. So I'm just going to tack it on here. That's not pretty. Probably shouldn't be done, but it'll get us there. So, all right. All right, we're so close. So here. Yeah, let's get rid of these arrows real fast. This is probably going to be okay for the most part. All right, let's put departure station service. Let me double check this. Okay. I think this will work fine. And then he's calculating the mean. I'm going to put np.mean in here. This definitely needs to be run though, because I probably need to look more closely at what these are doing, but I want to make sure to finish on time. So it reordered departure station by this is a tricky one. So this will be a Boolean, but then he's adding it to this percentage, meaning like when you're not international, you get 0 points, and then we add it to your percentage. When you are international, or when you're not international, you get 1 point, and then we add that to your percentage. So you're going to be high. When you are international, you get 0 points, right? So you'll be ordered as lower, basically. All right. Let's keep moving. All right, let's try to get this wrapped up. Okay. facet wrap. The one thing we need to do here is we need to convert these again to strings. And then the percent, oh, I did that, percent format, and then the wrap is also a string. Let's try this out. Oh, so close. Oh, wait, all right. Oh, that's not good. So something crazy just happened. I'm gonna have to go back and figure out. Let me, I'm gonna finish this plot off because it looks pretty routine, and then I'll go back. I think I have some suspicions. We need a plus sign. I'll add black formatting in a second. It'll probably do crazy things. Black's a great formatter. It's just the nature of some of these kind of nested things are. Yep. So it really expands out the code when we do things like FCT reorder. Yeah. So, which is sensible in some sense. So this is real bad. I think they're all maybe NAs or something. Let's see what could have happened. Since we did the summarize app before, it worked totally fine. Could it be that something about this went weird? Let's look at before the summarize. Let's just see. Give rid of that to what this looked like. I'm gonna move this into its own cell. Okay. Great. Departure by departure station month. This looks fine. And number of canceled trains, number of late departure. All right, let's see if we can run this again. Oh, here and here. So yeah, let's see if, is it the fast summarize? Did something go wrong? 5. Taking its sweet time. Oh yeah, something went wrong in fast summarize, so that'll be something for me to look into. I'm not because I'm not totally clear on what could have happened. Let me yeah, there must be. I wonder if it's related to multiple indices. I'll have to take a closer look. So since the fast functions have been pretty rigorously tested against a lot of methods, they might need to be tested against more forms of grouping. All right, so let's do this though. And I don't think we actually need to ungroup. In siuba, you don't have to ungroup against the summarize. For now, it's not. In dplyr, it returns a grouped data frame. Summarize does. In siuba, it ungroups the data frame. It might be implemented later. I'm not sure if it's something we can really support. I mostly just haven't considered that feature yet. Cool. So this is a lot of info. I mean, I wonder if he cut out some of these, if he lumped them. So this is pretty interesting though, looking at 2018 where you have like a lot more delays. Let me run this. I am curious about if his final plot, I think that, you know what happened is his final plot just ended up being taller. We could do that too. I don't remember how to change a plot height actually. I haven't done that in a long time in Jupyter. So Jupyter notebook, change plot height. It's probably a matplotlib option, I think. Let's see. Cool. Oh, okay. So this doesn't feel right. I thought there's a per cell option, but let me double check. So yeah, I don't know. So matplotlib inline. You know what, I'll do it for now. I might have to fix it because I don't want it to set all the plots to a specific height. But let's just do this for now, and then we can always change it. Right? Cool. Oh, that made it extra wide, I think. Or, yeah, I'm not actually sure. So let's do like 40. Just see. I don't know. I failed you. So I'll look it up and add it to the final result that I post on GitHub. Anyway, so that's a translation from R to siuba. I'll do the pandas translation later. I need to get a little bit faster with these. Hopefully that was helpful for giving a sense for the types of things siuba can do and what it looks like to map dplyr onto siuba. As you may have noticed, it's oftentimes just a one-to-one mapping, and there are some tricky things to work out with things like quickly summarizing and things like that. If you're interested, visit mhow/siuba on GitHub. Be sure to raise any issues or feature requests. I'm happy to answer questions or drop everything on my plate and just push whatever anyone wants. I'm ready to take requests. So thanks for watching, and I'll see you next time.